Welcome to Sea Machines webinar series. My name is Don Black and I'm the VP of Sales and Marketing at Sea Machines. The objective of the webinar series is to showcase autonomous vessel management systems and their practical application in maritime industry of today. We want to emphasize that what we're talking about today are products, not projects. So they're being utilized on a daily basis by mariners all over the world. So in this webinar series, we start off with a quick intro into describing marine autonomy as Sea Machines sees it, and then move into use cases and features that Sea Machines is currently employing in the field today. After our brief discussion in each webinar, we will be interviewing a current user of the technology in an effort to illustrate the practical and sometimes unique application of the technology. So let's get started. So what is marine autonomy? So essentially, almost all autonomy is categorized on some sort of continuum. In the marine community, we typically are looking at a 0 to 6 continuous scale, 0 being total manual operation, 6 meaning completely autonomous, no human intervention, 100% unsupervised automation. At Sea Machines, we think we're right between 3 and 4. So conditional automation means decisions and actions that are performed autonomously with human supervision. So there's always a human in the loop. And then you go a little further down that scale into the 4, and really what you're talking about is higher impact decisions. Still, however, a human is in the loop on a supervisory role. So what are we doing here? Well, we're trying to offload tasks from the human to the autonomous system. And this is not unique to the marine community. They often categorize it as anything that is dirty, dangerous, or dull. Dirty being the value or the use case is obvious. Dangerous, you want to keep people out of harm's way, whether that's sea state, whether that's toxic issues. And dull, of course, are usually elongated missions that have a propensity to create fatigue. And of course, wherever there's fatigue, there's the opportunity for human error. Okay, computing on the edge is simply meaning that we actually have a system on board that vessel that is doing the computing on board that vessel, not in the cloud. The SM300 or our Sea Machines product is at the core of that. And really what we're doing is we're automating the areas of steering and propulsion control. But how we're doing that is by understanding what's going on outside. So if you see in the far right-hand side, you'll see basically 4 pillars of our autonomy scale. And that is perception. Perception just simply means what is happening outside of that boat. So, and then you look at sensor fusion. Well, you understand what's happening outside of that boat by implementing certain sensors. And that can be radar, LiDAR, computer vision or camera, AIS, GPS. And all of these sensors are then fused together to provide a much more comprehensive perspective of what is actually going on outside of that vessel. And not only is it fused together to provide a comprehensive perspective, but it's meant to make it more consumable by humans. So in this case, you're not going to be looking at the radar individually. You're not going to look at the GPS or the propulsion individually. You're going to have it all together. And that provides a much more complete picture and a much easier picture to understand. And then of course, there's data. Data on top of that is the fuel that powers a lot of those perception techniques, which are based on machine learning and artificial intelligence. So understanding and having a tremendous amount of data to draw from is incredibly critical in defining the algorithms that are actually going to control that perception and ultimately that autonomy. And then finally, we're talking about UX or user experience. It's incredibly important to us and certainly to their customers that that we're working with, that they be able to be up and running very, very quickly. This should not take a degree engineer to be using this as an active tool. You should be able to get up and running in an hour or less in using our system. Okay, so autonomy today, a pilot assist or a human on board. So really, we try to categorize them into various areas. So smart route execution, you can see on the left-hand screen that graphic. It's really about waypoint autonomy. So you set a mission, you understand how fast you want to go between waypoints, whether or not you want to stall out or loiter on a waypoint, and then certainly always taking into consideration what's going on underneath the boat, what's going on outside of the boat. And that's where we employ obstacle avoidance on the right-hand side. So as you, I'm sure, very aware, there's always a propensity for a dynamic situation, which could be another vessel, could be an obstacle, flotsam, you name it. And so based on the parameters that you have tuned or commissioned your vessel to react to, that's going to be the way that you're going to avoid that obstacle based on obviously coal regs. Then we get into command modes, and command modes are more tactical. So collaborative autonomy is pretty much exactly what it sounds like. You're talking about a digital tether from one ship to another, or in essence, a mothership and a daughter ship. Obviously, the value there is you can have multiple vessels essentially doing the same mission or similar mission at one time. So it's force multiplication in areas of swarming, or when you want to employ multiple vessels at one time. The remote helm and remote operation are slightly different. So remote helm is in the middle. That's when you have a system where you have a person with a belt pack, they have the controls right at their side. And in this case, this individual is actually controlling that skimmer that you can see off in the background of the picture. But there's a line of sight there. On the control side, control center side and remote operation, really in this case, Captain Lauren Lamb is actually controlling that vessel and managing that vessel operation from an office wherever she wants to be. This is effectively anywhere in the world. And she's going to be able to create the missions, deploy the missions, abort the missions, anything that you could otherwise do on the boat, she can do right there. And of course, if you see in the bottom in this particular case, there's a lot of video interaction and the like. So there's a tremendous amount of situational awareness that is attached to that remote operation when you don't have a line of sight. Okay, so where do we see this all going? Well, it's really dock-to-dock autonomy is the end game, or when you look at level number 6. So you basically are saying, hey, listen, I want to go from A to B. We know that there's going to be a very dynamic situation, whether that's sea state, whether that's other vessels in the water, or you name it. We want to be able to instantly react to that and get to our final destination. That's ultimately what full automation is about. Having said that, where we are right now is in with that that human in the loop, so that supervised offloading of effort to that autonomy engine, and that's where we are right now. And certainly we're excited about where that's going and how that's being implemented. Okay, so on to really the point of this webinar series, which is to have a discussion with a group of individuals that are actually applying our technology, are practically applying our technology. So Autonomy in the Classroom is the title of this particular webinar series, or episode, excuse me, and bringing intelligent technology into the curriculum. I'm really pleased to introduce to you Captain Jennifer Norwood. She is the Assistant Professor at Maine Maritime. Welcome, Captain Jennifer.
Thank you so much, Don, about having me. I'm very excited to be here. So a little bit about Maine Maritime Academy. We are located on a small coastal town in Castine, Maine. And it's really kind of a unique atmosphere to do that sort of maritime training. We have about less than 1,000 students, and we're really spending time to equip our students with practical skills, knowledge, and training. We're providing a hands-on education, both with engineering, marine transportation. We do co-ops and cadet shipping and commercial vessels. We also have a business program that is international and maritime focused. And we provide our opportunity for our students to learn from new technologies as they start to emerge. And so when we look at sort of the challenges, the maritime industry is changing so fast, and with this new maritime disruptor of autonomous vessel technology, it really is important that we take it and bring it to our students. And so we're preparing these students for the future, and we need to make sure that they're up to speed on the latest technology and they're familiar with it. And although it's a little uncomfortable, the idea of autonomous vessel technology for some of the students, it's important for them to either have exposure to it, training on it, or some sort of education to really maintain that competitive advantage and make them much more attractive to the clients out there and to the companies out there who are looking for the advanced student who really understands this technology. So what we did is we had a nice opportunity to work with a collaboration of Sea Machines and MARAD and retrofit onto the Quickwater, which is a 41-foot U.S. Coast Guard utility boat, the SM300. So we have in there the radar, the AIS cameras, and we're using sonar. And we're able to operate it in the remote control mode. We're also able to operate it on board creating the missions, and we're currently working towards operating it from a shore control center, much like Captain Lauren Lamb did. We are going to create that shore control center so that we can expand on our training. And so kind of when we look at it, how are we going to leverage this technology? Our first steps are to really introduce our students to this technology, get them experiencing it, seeing it firsthand on the vessel itself, operating it remotely, really kind of opening their mind to what the possibilities are in the future. And then we're going to bring in students and start sort of bringing in what they feel from it, what they experienced on it, how it worked for them. And then from there, we're going to implement them and put them into a shore control center where we can really take the student who is a tactical hands-on learner, put them into a control room and have them problem solve issues with their minds instead of their hands. And so our students are used to being able to going out to the vessel or going out to the piece of equipment when it fails to look at the problem. Here, they're going to have to do it from a shore control center and really tap into their critical thinking as well as their teamwork. Because now you're looking at having a deck officer, a engineering officer, possibly an IT person, all in the same room trying to make decisions together as a leadership team for how to solve the problem. So kind of when we look at this, we're working towards creating the shore control center, and these benefits are huge for our students. They're going to really give them the experience of what the future of the maritime industry looks like, and it's going to give them the opportunities to come out into the industry having already experienced what this change in the industry, and it's going to happen really quickly. Additionally, our shore control center is going to bring in the feed directly into the control center, and we're going to also have students sort of monitoring the vessel out on the water at the same time. And then we're going to bring the engineer in, and we're going to collect emissions data, safety performance data. We're also able to feed that back into a medium speed engine room lab that we have on campus and recreate that environment so that we can also create a situation where we can do, we can create problems or fails for the students to kind of have to figure out what's going on. And this is really where the training kind of comes in. It's easy to operate a vessel when everything's going okay. Now we're removing them from the vessel, and if everything's going okay, it's no problem. But really when we come and test them and their knowledge is when we start putting those failure modes in where something fails and now they have to figure out what's the next steps. So the Marine Engine Testing and Emissions Lab, it's going to do two things for us. We're going to really monitor and record the energy efficiency or the efficiency of the engine in a manual mode compared to in a autonomous mode and really see what the benefits are from an autonomous mode. In terms also, we're going to be able to bring this into the engine room and really share it with the students and really kind of get them thinking, what's the future look like? Additionally, we're going to really work on this sort of situational awareness. When you're on the vessel, it's easy to step out the side of the wheelhouse, look out, see everything around you. When you're removed from the vessel, you're going to have to rely on the technology of the vessel to do that for you. So it's really important to do that. In addition, this technology is going to really help them use all this knowledge that they've been building, and it's going to pull it to the forefront and really tap into that.
All right, so this is the time when I want to kind of have a more casual conversation, a little bit of a Q&A. And by the way, any questions we don't cover now, please feel free to send us questions and comments at sales@seamachines or jennifer.norwood@mma.edu. But you touched on some of the things that I wanted to discuss, but to be clear, given the recent, what has been the impact on the daily lives of students at MMA? Are students back on campus? Is it partial, live students, or is everybody remote? How is it in your particular academy?
Yeah, so for us, we have a little bit of both happening. Our students are back on campus. However, they're not in all their classrooms all the time. The challenge is that you can't really have that many students in an academic building at once. So they're really kind of either going to be online where they're on campus, maybe in their dorm rooms, and they're doing their work from their dorm room where they're having an online lecture. Or they're going to have a hybrid model where their instructor or professor might have them one day in the classroom, half the class, then another day have the other half of the class, and then on the third day, they're all online. And that's really for our lectures. For our labs, they're all face-to-face, they're all hands-on.
No, it sounds like you guys are very prepared. So, when I look at this, and this is from an outsider looking in, and, especially with the, the offsite control center and the fact that you want to give your students as much hands-on time as humanly possible, well, that's a difficult thing to do right now. And, for all the social distancing. I mean, when you look at that shoreside control center, do you see that as an extension of the classroom that maybe helps you provide a more practical experience for the student?
Yeah, I mean, as we started this sort of project with the Maine Maritime, we weren't really thinking beyond. But then when we started thinking about virtual labs, really the thought came forward of, well, if we have the quick water out there and it's able to operate and the students can actually tap into the shore control room and see what's happening, they might be able to actually use that for some of their virtual labs. So if they have some terrestrial navigation things that they have to really work on, if they're talking about, the passing of vessels, using the coal regs, these are opportunities that we might be able to use this shore control room in a virtual lab perspective if we have to really go into the long haul. And that opens up an exciting opportunity, because once you add that shore control center in there, you really open up the opportunity for all students to be a part of it, but remotely. So they don't have to be on the vessel and they don't have to be in the shore control center. They can be in their dorm room watching from the computer.
Yeah, and essentially a virtual lab or a virtual demonstration, and I think that makes a whole lot of sense. So, when you look at all this, how are the students embracing it? And you touched on it a bit, but is there any kind of practical examples in terms of students, particular experiences? Are they, well, I guess the question is, are they embracing it? Is it, do they see the value in it? What's your perspective on that?
So, in a short answer, yes, they're embracing it. Would I say that everybody's thrilled and excited about it? No, not so much. But usually once they experience it the first time, they really get excited about it. They're excited about the opportunities, excited about what the vessels can do. It just really opens their mind to how much the maritime industry is changing. And so when I talk to my students about it, and I have a group that are going to kind of start really working with the quick water, they're excited about what it can do. And then as we go further, I'm working with the Marine Systems Capstone group, who are really going to help, contribute to the quick water and opportunities to add additional things that we can bring into the control room, different sensors, possibly adding the fuel gauge, the level of the fuel gauges, so that we can really bring the shore control center up in scale, where we can operate the vessel completely from a shore control center. And that's a sort of project in progress. We don't have it all there yet, but it's something we're working towards. But our students ourselves are pretty excited about the technology, and they really want to see it in action.
Well, I think that's very forward thinking, and I look at MMA being the first to embrace the autonomous systems and really kind of preparing their students. Is it a mandate, or is it a conscious effort of Maine Maritime to be on that leading edge or bleeding edge of innovation?
I think it's more of a conscious effort. When we introduced and talked about the idea, it was easy for it to kind of be a quick sell. And as we started to really bring the quick water to campus, it went from sort of this idea to this realization, and it really got a lot of people excited. I have people on the waterfront who are really excited to engage in it and work with the students. And then I have people up in the administration who are really excited about the opportunity to move our curriculum forward for new technology. So really, it even though it started as sort of a small idea that's kind of blown up, it's really going to provide the gateway to our students for this new technology. And it's really important. And everybody on campus is seeing the value in it. And the beauty of it, it is interdisciplinary. It doesn't just apply to the Marine Transportation Department. It doesn't just apply to the Engineering Department. It's applying to both across. So it's a really exciting opportunity to have students really working together from different disciplines.
Excellent. So, perhaps a slightly more provocative question, but what is your response when some mariners believe that this is going to reduce opportunities for mariners, as opposed to, frankly, my position which is, I think it's going to expand, but I'd love to hear your opinion.
So for me, I really think that if students are thinking it's going to reduce their opportunities, then they're really thinking very narrow-mindedly. It's not going to reduce it so much, but it's going to change it. And when we talk about changing it, it's really going to enhance their knowledge already. When we move from, as we start to build the curriculum and we start with one class, such as an interdisciplinary autonomous vessel technology, where we introduce both the engine room, the control room, and the vessel all at once to different students from different disciplines, and we expand beyond that, I can already see maybe a minor in autonomous vessel technology to the long term being you choose autonomous vessel technology as a major, and then you choose a path, whether you're going to be a navigator or you're going to be a sort of engineer troubleshooter. And I really can see that it's going to develop quickly. So for students, I think it's hard for them to kind of quantify it or see it, but once they start seeing it in action, they know it's coming. For these students, they are used to technology, so it's going to be easy for them to follow into it. But what it does is it's going to open up more training and more knowledge in a more specialized area that's going to eventually apply to a lot of the maritime industry. So from my perspective, I don't really see that it's going to be a negative, although I know there are many people who feel like it's going to maybe take their jobs or they won't have opportunities. The truth is they are trained mariners. They're going to be needed, regardless of whether they're on the bridge or in the engine room. Their knowledge and their training is still going to be in demand. It's just going to look a little bit different.
Yeah, no, that seems to make a lot of sense. And when one looks at how crowded and congested the terrestrial highways are, and being able to place some of that movement back into the marine transportation and do it efficiently with new technology, whether that's autonomous systems or otherwise, it would seem like that it makes an argument for job expansion very likely. So I think that's
and I think,
an interesting perspective.
When you focus on the safety side, it's going to make their jobs safer, and it's going to really eliminate, as you mentioned, the dull part of the job, where sometimes it's tough to just be monitoring on a vessel. In some areas of the industry, some of these mariners are just monitoring and they're not interacting, so that sort of boredom creeps in. At the same time, it's going to correct for itself. It's going to deal with the incoming environments and make corrections so that you can alleviate that need for the human intervention, but you don't take the human out of the loop. So I really think that it's going to open up opportunities that are different. They're going to look different, and the industry is going to look different, but it's still going to require those trained mariners. So
yeah, the predictability of that mission, I think, goes up, and it doesn't necessarily take the human out. So that kind of wraps up the amount of time we had. And Captain Jennifer, I really want to thank you for taking the time out of your incredibly busy schedule to have a chat with us. And I really do encourage anybody that watches this video to drop Captain Jennifer an email and pick her brain about some of her experiences. They're much wider than what we've had the opportunity to talk about today. But thank you so much for joining us on the first webinar series.
Thank you so much, Don, for having me. I look forward to talking in the future.